Relativity. The ether versus Einstein, round 2. First, let's do a simple relativity experiment. Take two accurate, identical and synchronized clocks situated side by side. The clocks part and take different journeys. Eventually, they reunite. One clock, let us say the red clock, now reads the other to be slow. And naturally, the blue clock reads the red clock to be fast. Now, which physics theory explains this strange result? The usual answer is Einstein's special theory of relativity. But there is an alternative, the ether theory of relativity. In order to clearly see the difference between the two theories, we now specify the clock journeys so as to maximize the inertial periods. Inertial means having constant velocity. The red clock remains inertial throughout, and the blue clock accelerates away from the red clock and recedes at a constant velocity for some time. It then rapidly reverses direction and returns to the red clock at the same constant velocity at which it left. During the inertial periods, both theories predict that each clock observes the slowing of the other. This agrees with the final observation of the red clock. But the final observation of the blue clock is the exact reverse of this expectation. To obtain the observation of the blue clock, some other effect must occur. This effect, called the COV factor, can only occur at the reversal of the blue clock. It must create a fast reading of the red clock of exactly twice the total time slowing effect. Einstein's relativity does not contain such a factor. Neither can any other law of physics create this effect. But the ether theory of relativity intrinsically includes the COV factor. For those who have an interest, here is the ether relativity equation for the observed time measure. In the clock paradox, Vd equals 0 for the red clock and 2v for the blue clock. Conclusion: the ether theory of relativity is the correct theory, and therefore space is an ether.